Welcome back. So today, once again, we're considering geometric series. However, we're going to focus on when it's written in summation notation. Now, geometric series in summation notation, they're going to look like this. They actually look a lot like the exponential functions that we were working with back in chapter 7. So, what I want you to see is you're still looking for the same pieces. You still need to know what A1 is. You need to know what n is, which again, hopefully you remember, is that term up top telling you that you're going up to the 10th term, and then your rate. So, two things we still have to figure out here. Well, the rate is actually just whatever is being influenced by the exponent. So in this case, your r is going to be 5 because that is what is being influenced by the exponent. The first term, if you remember from when we did this 2 lessons ago, the first term is when you plug 1 in for n. Well, 1 minus 1 leaves us 0. Well, 5 to the 0 power, well, anything to the 0 power just cancels off, is 1. So all we're left with is the 2. So there's the calculations to find the pieces that we need. Now we actually have to plug it in to our summation notation formula. So I'm going to change colors for that so you can tell the difference. Where now I'm transitioning, I'm actually going to find that sum. So A1, which we said is 2, 1 minus r, which is 5, to the 10th power over 1 minus r. All right, let's plug that into our calculator, shall we? So 2 times 1 minus our r, which is 5, to the nth power. In this case, n is 10. So we plug that in to get the top of our fraction. And you can tell it is a huge number. So I'm going to write that out. Over 1 minus 5. Well, 1 minus 5 will give us a negative 4. So essentially, we need to take that number that we just got and divide it by negative 4. When we do that, that is going to be our final answer. All right? So again, really there's not much new today except making sure you know how to get the pieces from the summation formula. Otherwise, the calculation and everything is precisely the same as what we were doing before. So let's try it again. So our first term is when we plug 1 in for the exponent. Well, that actually makes it easy because anything to the 0 power becomes 1. So that's just going to leave us with 3. Our first term is just 3. N is whatever number we're counting up to. We're counting out 9 terms. And R is the number that is being influenced by the exponent. So in this case, R is going to be negative 4. So let's plug this in. Our sum is going to be A1, which is 3, times 1 minus negative 4 to the 9th for 1 minus R. So we need to calculate the top of this. 3 times 1 minus the negative 4 to the 9th power and we get 786,435 divided by 1 minus a negative 4. Remember, subtracting a negative is the same as adding. So 1 plus 4 gives us 5. So we take our answer. We take that number, we're going to divide it by 5. So we get 157,287. That's going to be our final answer for this one. So let's do one more again, just to make sure that you're understanding the keystrokes and exactly what you need to be doing. So we need our first term. Well, again, our first term is where you have to plug 1 in. Well, 1 minus 1 is 0. So that piece cancels off, and I'm just left with 6. Need our n. Well, in this case, we're counting up to 8. So we're going to have 8 terms. That rate, that r value, is whatever is being influenced by the exponent. So in this case, 0.5. All right, so let's plug all this into our summation formula. So a1, which is 6, times 1 minus r to the n over 1 minus r. So let's plug that into the calculator. So 6 times 1 minus r, which is 0.5, to the 8th power, and we get that. All right. So 5.9765625, and 1 minus 0.5 is 0.5. So now I take that and I divide it by 0.5. All right, so what do I get? Well, I get 11.953125 as my final answer. Okay, now again, please do not be rounding these. This again is a nice terminating decimal, so it has an end. If it doesn't, then you're going to have to be able to turn it into a fraction using the calculator. But just make sure, please, that you're not rounding too much, because if you round, it's going to influence your answer in the end. So thank you again for joining me. Please make sure you ask any questions before you do your practice work.